Welcome back. Let's do question 332. In the diagram, A, B, and C are the vertices of triangle ABC. T is the midpoint of CP. The equation of the line AC is 5x minus 6y is equal to 8. Then the angle of inclination of AB is alpha. We managed to find that alpha is 108.43 degrees. And then we managed to find that this angle is 39.81 degrees. And then we found that this one is 68.62 degrees. Triangle DCT is drawn such that CD is parallel to AB. The lines AC and DT intersect at S, the y-intercept of AC. P, F, and R are the x-intercepts of DC, AC, and AB respectively. Calculate the area of POSC. POSC, let me just highlight that. We want the area of POSC, which is this. So what we can do here, we can find the area of PFC. We can find the area of triangle PFC, and then find the area of triangle OFS, and then we subtract. We subtract the area of triangle OFS from the area of triangle PFC. Now, how can we find then the area of triangle PFC? We can use the area rule because we have this angle. Because this angle, these two angles are equal because they are vertically opposite. So let me write this angle here, 39.81. So now if we can find the size of PF and then the size of CF, then we can use the area rule to find the area of triangle PFC. But the area of triangle OFS, we can use the formula half times base times height. So we need the coordinates of these points. We need the coordinates of P, we need the coordinates of F, we need the coordinates of S, we need the coordinates of C, right? We have the coordinates of S, which is 0 and -4/3. So we can write that. Here is 0, the -4/3. Those are the coordinates of S. We need the coordinates of P, F, and C. We have the coordinates of C. So we need the coordinates of P and F. Let's find the coordinates of P first. Right, P is the x-intercept of the line CD. We managed to find the equation of CD here in question 3.2. So we can find the coordinates of P, which is the x-intercept of CD, right? So you see, using this equation, y is equal to -3x minus 9. Then where there's y, we put 0. 0 is equal to -3x minus 9. Then 9 is equal to -3x. X is equal to -3. So it means P is -3, 0. The coordinates of P are -3 and 0. Right? And then F is the x-intercept of AC. We have the equation of AC here. We have the equation of AC. So we can use this equation to find the coordinates of F. 5x minus 6y is equal to 8. And then we can find x. Where there's y, put 0. 5x minus 6 times 0 is equal to 8. Meaning that x is equal to 8/5, which is 1,6. So it means here F, we have 8/5, 0. 8/5 is 1,6. Okay. Right, we have the coordinates of C. Right, now we can then find the length of PF. The length of PF. So we can say here is 3, from the origin to -3 is 3 units, and then from 0 to f here is 1,6, meaning that PF is actually 4,6. PF is 4,6. Let's write that here. PF is equal to 4,6. Right, we need to find CF. And then to find CF, we can use the distance formula. The distance formula, because we have the coordinates of C and the coordinates of F. Let's use the distance formula to find the length of CF. So CF is equal to the square root of -2 minus 8 over 5. So it's -2 minus 8 over 5 squared plus, then the y, -3 minus 0. So -3 minus 0. We're using the distance formula to find CF. And then if you put this in the calculator, you get that CF is equal to 3 times square root of 61 divided by 5. So let's write that here. This is PF actually. PF, not P. And then CF is equal to 3 times square root of 61 divided by 5. Right now we have a side, angle, side. We have two sides and an included angle. We can use the area rule. So the area rule will say area of triangle PFC is equal to half times PF times FC, then sine 39,81 degrees. Okay, then meaning that this is half times PF. PF is 4,6, and then FC is 3 root 61 over 5, and then sine 39,81. Right, you can put this in the calculator. You'll get that the area of PFC is 6,9 square units. Okay, right now we have the area of PFC. We can find the area of OFC. OFC, we're going to use half times base times height, because this is the perpendicular height. OS is the perpendicular height, because OS and OF are perpendicular to each other. So this OFC is actually a right angled triangle. So OF is 1,6, and then OS, because it goes to -4 over 3 there. So it means OS is actually 4 over 3 units. So you can say area of triangle OFS is equal to half times base, which is 1,6 from 8 over 5. And then times the height, which is OS, which is 4 over 3 units. 4 over 3. Okay. Right? And then with the distance of OS here, just say 0 minus -4 over 3. That is 4 over 3. Right? And then what we get that the area is 1,07. Now, we want the area of POSC. So we say the area of PFC minus the area of OFS. That will give us the area of POSC. Therefore, area of POSC is equal to 6,9 minus 1,07, in that the area is 5,83 square units. Okay, that's how you can do it. Right, the other way we can do this, I'll just explain this. Right, we can use, if you check the triangle PFC, is its perpendicular height. This is its perpendicular height, which is going to be from 0 to -3 here, meaning that its perpendicular height is 3 units, because it's from the x-axis up to -3, so it's 3 units. And then the base is going to be PF. The whole PF, we said, is 3 plus 1,6, meaning that PF is what? PF is equal to 4,6. So the area of triangle PFC, you just say area is equal to half times base times height. So you say area of triangle PFC is equal to half times base, which is 4,6, the whole PF, and then times height, which is 3. Okay, this will give you the area of PFC. And then the area of OFS is still the same. It's going to be 1,07. So to find the area of POSC, you say the area of PFC, which is this, minus the area of OFS, which is this. And then you're going to get the same answer. Okay, you can try that and see.